Good day. So we are doing physics and we're going to be looking at vertical projectile. We're going to be focusing specifically on graphs. So without wasting any more time, let's get into the video. So we're going to be looking at how to draw the acceleration versus time graph. So I'm talking about this graph. This is probably the easiest graph you'll find in vertical projectile motion. So, and this graph, it always stays the same. It's either, let me view, it's either it will be a line here or a line here, depending on your direction. If you don't understand this, it's fine. I'll explain it more clearly. So, this graph actually, let me redraw it. This is time, and on the y-axis is acceleration. This acceleration, so now we are dealing with vertical projectile motion, right? We are dealing with objects that are moving under the influence of gravity, right? So, for example, let me just say a man who's at the top of the tower. He dropped a ball here, right? And then this ball will go down, right, until it reaches here, right, and bounce back. So this ball here, when it's dropping, it experiences a force, right? And the force is called the force of gravity, right? And then what you will realize is that because this ball was dropped, its initial velocity will be 0. But like if this man throwed this ball, then its initial velocity will not be 0. It will be a certain velocity, right? So what you need to notice is that once you drop this ball, as it goes down, its velocity increases. The velocity of the ball, let me actually do this. Okay, now the velocity of this ball, right, at point A will be bigger than when it was here, right? It increases as it goes down, right? And there's a reason why it increases. And even if we also look at point A and point B, the velocity of this ball when it gets to point B, it will be greater than the velocity of the ball at point A, right? And the reason being the gravitational force, Fg, right? It's pulling this ball down. And we do know that this formula, right? F net is equals to ma, right? Where there is a force, also an acceleration is there, right? They exist together. One cannot exist and then the other not exist. So due to this force of gravity, this ball, once it's dropped, it will have an acceleration, right? That's the reason why it's increasing. Its velocity keeps on increasing as it goes down, right? And this acceleration, we call it the gravitational acceleration because it is the acceleration due to gravity, right? So now, this graph right here, and another thing before I continue, the gravitational acceleration, which is g, the gravitational acceleration, its symbol is g, it's equals to 9.8 meters per second squared, right? It's a constant. It never changes. Why does it never change? Because the force of gravity does not change, right? It pulls as the same force, right? So even the gravitational acceleration is the same thing, right? It does not change. It's a constant number. So when they tell you to draw an acceleration versus time graph of an object, right? of an object, no matter the scenario, what you need to know is that this will be 9.8 and here it will be 9.8. So there are only two types of graphs you can have when we are dealing with acceleration versus time graph. There are only two types. It's either your graph will look like this, right? Or your graph can look like this, right? There's only two types that you will find, no matter the scenario that they give you. So when do we get the graph to be like this? When do we get it? It depends with the direction that you choose. You do know that in physics, when we're dealing with vectors, right, we need to choose a direction, right? So let's say, look at this scenario here. A ball, this man is dropping a ball, right? This ball is going down, right? And then they ask us to draw an acceleration versus time graph, right? So as you can see, this graph, the line for the graph for acceleration, it's on the negative side, right? So we know that it's 9.8, it's negative 9.8 meters per second, because on the negative side per second squared, right? So why is it on the negative side? The only reason could be if we chose up as positive, because if we chose up as positive, anything going down is going to be negative. Anything going down is going to be negative. So gravitational acceleration, we know that Fg goes down, right? That's the force of gravity, and its acceleration is also down. Gravitational acceleration is also down, right? The ball, as it goes down from here to here, as it goes down here, its speed is increasing, right? It's increasing as it's going down, meaning it's accelerating downwards. So the gravitational acceleration in this case is negative. Gravitational acceleration, I'm talking about this g, is going to be negative 9.8 meters per second. Why is it negative? Because we chose up as positive. Now, in this example, they chose up as positive. How do I know that? It's because of this. This graph is drawn here in the negative side to indicate that. But if I would have chose down as positive, if I would have chosen down as positive, then because gravitational acceleration also goes down, this g, it will be positive. I'll write it as a positive number, which will be negative 2. Then the graph will now be like this, and it will be positive 9.8 meters per second. Now, it doesn't matter the situation that you have. Take a look at this. Another situation, the same type of graph is always a straight line. Why is it a straight line? Because the gravitational acceleration is constant. Even when time increases, the gravitational acceleration is constant. Another situation, where you toss a ball up, it comes down, still the same graph. The only thing is that they chose upward as positive, right? And because gravitational acceleration goes downwards, right, then it's going to be negative. Same scenario, another scenario, same type of graph. It doesn't matter the scenario, the graphs will be the same, right? So yeah, thank you.